Hello, I'm Ruth Green for Global Island News, and I'm here today with Mike Johnston, CEO of Nautilus Minerals, the first company to commercially explore the seafloor for massive sulfide systems, a potential source of high-grade copper, gold, zinc and silver. Welcome, Mike. It's a pleasure to have you here today.
Thanks, Ruth.
In terms of the deposits that Nautilus is targeting off the coast of Papua New Guinea, what is so attractive about them?
The thing that's attractive about seafloor massive sulfides, it's not just in Papua New Guinea, it's all over the ocean where you get these systems occurring, is that they are very, very high grade. So the system that we're looking at in Papua New Guinea, for instance, the first one, it's got a grade which is about nearly 15 times higher grade than what the deposits on land are. So it's the high grade which makes them special and different to what we do on land.
And as I understand it, there are three main components for the Sawara 1 offshore production project. Perhaps you can give me a brief outline of the three components.
Yes, certainly. The three components are the mining tools themselves, and then the riser and lifting system, and then the vessel, the seafloor production vessel. So the mining tools comprise three tools. Their job is to disaggregate the high-grade material on the seafloor and then transfer it to a stockpile and then transfer it to the riser and lifter system. The riser and lifter system comprises a large pump which sits at the bottom of a steel riser system. The pump pushes the material up the riser system, so the material is a slurry of water and the ore, or the high-grade material that we've cut with the machines. That material gets pushed up the steel riser pipe for about 1,500 metres, and it goes up into the vessel, and then on the vessel we have a dewatering plant which separates the solid material from the water, and then the water gets returned down two small pipes on the outside of the larger pipe in the riser system, and it goes all the way back down to the pump under pressure, and it's that pressure which drives the pump, and then it gets exhausted back onto the seafloor where it came from.
And in terms of the timeline for commercial extraction, how is the project progressing?
The first ore is expected in the first half of 2018. What determines that timeline is the building of a new vessel which is under construction. It's being designed at the moment and is being designed and built in China. In fact, I think we're cutting steel next week, so the actual physical build will be starting, and the design work is just about complete. And then building the vessel takes till the end of 2017. Then we take possession of the vessel, put all our equipment onto it, bring it down to Papua New Guinea, and then start mining.
I'm interested in discussing some of the technological and physical challenges of deep sea mining.
Probably the biggest challenge for mining on the seafloor is what they call the hyperbaric effect, which is the pressure of all the water above the material. You have to design systems to be able to handle those increasing pressures. The technologies that we're using are all being used around the world, either in the oil and gas industry. So the riser system, for instance, that I described previously, that's straight out of the oil and gas industry. The pump is built by GE in Houston. The cutting machines that we're using are built by Soil Machine Dynamics. They build a lot of trenching equipment for the deep sea and ROVs. So what we're doing is taking technologies which are already out there and bringing them all together in a slightly different way to be able to produce very, very high grade ore, bring it up onto the vessel and then sell it directly to the market.
Mm-hmm. And how did you go about deciding to use the particular partners that you are using for different aspects of the project, whether it's the build or for the different technologies that you're using?
Well, firstly what we did was that we had what we call a series of design challenges. So we said, this is the problem. We have this very, very high grade material sitting on the seafloor, 1,500 metres, some of it 5,000 metres, so much, much higher grade than on land. We had workshops with environmental groups, NGOs, regulators, and we asked people, what they saw as challenges. And the challenges that people put up to us, some of the environmental challenges were people didn't want to see the mixing of the seawater. So the ocean is stratified. So where we are in Papua New Guinea, the water temperature is about 28 degrees Celsius It varies about 1 degree, so it can get up to sort of 30. So much warmer than what you get in the UK, right? So, and that's what it is at surface. And then, but when you're down at 1,500 metres, the water is the same everywhere, whether it's on the equator or on the poles. The temperature is about 2.5 degrees Celsius, and the pH is about 8.6, so it's slightly alkaline. So, and people didn't want us mixing those different bits of the water column, because the nutrient levels down in the deep ocean are different to up on the shallow water, and cooler water has, animals are all evolved differently to accommodate the differences. So that was one of the key criteria, plus the need to be able to just extract the ore. We didn't want to be mining waste. We didn't want to create the same sort of issues that you have on land from mining. Said, okay, these are the challenges, these are the constraints that this system has to be able to contend with. Let's see, show us your design, and then we took the best of those and went forward with those design, right, and that team. A lot of people don't realise it's not a little tiny company. And it's the same thing with the vessel. You look at our vessel, where the vessel's been built in China by Fujian Maui shipyard, which is one of the oldest shipyards in China. I've got Rolls-Royce providing the thrusters and engines for the vessel. Siemens in Germany provide all the electrics through it. Kongsberg in Norway, all the navigation, all the bridge. Badeschi in Italy are doing the cargo handling stuff. So it's all the niche areas are being done by the best in the world at what they do.
Just as with land-based mining, environmental compliance is a key issue with seabed mining. I just wondered, what are sort of the ways that the company has been informed in terms of environmental compliance requirements and due diligence processes?
We've done an EIS, so a very comprehensive environmental impact assessment of the site. The Sawara 1 site is probably I would say the most studied deep ocean site in the world. When we go back to, we've documented changes, because the system is what we call a waning system, where we're going to mine. So the system, it's a hydrothermal vent system, but it's dying basically. It's turning off, and the active site is actually further, about 2 kilometres from where we're mining. And that area we're leaving completely undisturbed by mining. It's what we call the reference site. And it's being left alone because we care about biodiversity, and that's the active venting site, and that's where most of the biodiversity occurs. We work with the regulators, not only in Papua New Guinea, but when we did our EIS, we involved a lot of institutes who we considered, once again, like the design work, we considered to be the best in the world.
There has been research that suggests that biological communities are able to recover from even violent eruptions under the sea.
The general consensus is that these sites will recover within a very short time frame. The concerns that people are starting to mention to me these days are more to do with the cumulative effects of mining lots of these systems, and the interconnectivity of the systems. And we're starting to do work on that at the moment. We don't expect we're going to mine every system. You'll probably only mine 1 in 20 of these things, and there's thousands of these systems all over the planet.
Earth Economics published a report earlier this year which actually compared Sawara 1 very favourably with a number of terrestrial mines. And I think there were 3 projects that it compared it with.
Yeah.
Which projects were they?
One was a mine in the United States called Bingham Canyon, which is a very large copper mine in Utah state. It's been going for nearly 80 or 90 years, I think. It's a very big copper mine. It's pretty much a standard large-scale copper mine. So that's what mining has to do these days, because the grades have come down so much. It's all about economies of scale. So, if you look at the grade of copper mined on land 30 years ago, it's nearly twice what it is today, right? So the demand keeps going up, and to accommodate the demand, we basically have to build bigger and bigger mines, have bigger and bigger trucks, and move more and more material. The other mine that was looked at was a mine in Australia called Prominent Hill, which produces about the same amount of copper and gold that you would expect from a seafloor massive sulfide deposit like Sawara 1. And then the other mine that was looked at is one that still hasn't been built yet, but it was in an area. It's called Eintag in Ecuador, in the rainforest. So we're looking at something about the same scale. We're looking at something which is going to be more of what it's going to have to be done if we're going to have copper and we need copper. And the other one is, okay, an environmentally sensitive area. And when you compare them to seafloor mining, the results of the report are quite startling in that seafloor mining comes out much, much better than all three of those. And just in terms of the impact on ecosystems, the impacts are significantly less, right? So, and that's largely because with seafloor mining, the seafloor massive sulphides, we don't have big waste dumps like you do on land. You know, that's one of the big benefits of seafloor mining. So on land, for every tonne of ore that you mine, right, that tonne of ore on average has only got 0.6% copper in it. And to get to it, you've got to mine 3 tonnes of waste. And that waste has to go and be put in a dump, waste dump, and it's there forever, right? And you end up, when the mine's finished, you end up with this great big hole in the ground, you end up with these big piles of waste dumps, which these days people engineer, and we try to make them so they're as stable as possible, and we try and make them so that they don't leach acid like they used to in the old days. You know, in the old days they just put them to the side, and they didn't realise that, you know, what you're doing is exposing sulphides to water and oxygen, and you got a long-term liability because it impacts on the groundwater. And also, you know, big mines on land have these massive tailings dams. You know, so for every tonne of ore that you process, right, you end up with volume, nearly twice that amount of volume in the tailings dam because it expands, right? So you end up with these great big long-term liabilities of tailings and waste, which you don't get with seafloor mining, and that's a massive advantage. The other big advantages are the fact that the CO2 footprint, if you like, to produce that tonne of copper is much less from seafloor mining because you don't have tens of trucks running around, you don't have hundreds and thousands of people involved in electricity to crush all this, because you're basically taking a mountain of low-grade copper and crushing it down into sand to release the copper on land. Whereas what we do is we disaggregate the material on the seafloor, we pump it up onto the vessel, right, we dewater it, and we ship the high-grade material to China, and where it gets to China, the Chinese will be taking the material and producing copper ore as well as sulfuric acid for fertiliser, gold from the tailings, what would have been tailings, and iron ore. And there's no tailings at the end of it all. So those are massive advantages. And so you've got much lower CO2 footprint, you've got virtually no waste, you've got no tailings, and they're all big negatives for mining on land.
And so really there seems that there's a lot of advantages of deep sea mining in terms of higher output, higher capacity, reduced environmental impact. Do you think then that really raises the bar for what we would expect of traditional land-based mining?
The Earth Economics report, I really like that, that type of reporting. What natural capital accounting does is then takes that knowledge of the environment and then compares different ways of interacting with it by assigning values to the environment and dollar values. You have to make informed decisions. And then what you do is then say, okay, this is the strategy we're proposing, and we can then evaluate what the impacts of that strategy are. And when you do it that way, you go, okay, well, that impact here might be too much, so can we reduce that impact, dollar impact? And you can reduce it sometimes by doing things differently, right? You know, I've spoken to some friends in the oil and gas industry, and they hate natural capital accounting. I mean, one guy said, "Yeah, they count every mosquito," you know, and I'm thinking, well, yeah, that's not a bad thing, you know. You want to know the full environmental impact. I think it raises the bar for all of us in the extractive industries, and it's making us all think more holistically about the planet, you know, because at the end of the day, you know, we all need copper. You know, if we want to have televisions and iPads and everything, you know, we need copper, and our consumption of copper is increasing. It basically doubles about every 12 to 15 years. So when I first started in the mining industry back in the late 80s, you know, the world was consuming about 5 or 6 million tonnes of copper a year. Now it's consuming about 25 million tonnes of copper a year. You know, by 2030, I think, or 2040, it's going to be consuming nearly 40 or 50 million tonnes of copper a year. So you have to ask yourself, where is that copper going to come from, right? If it's going to come from land, which is only 30% of this planet, you're going to have a massive problem, because what it means is you're going to be mining lower and lower grades. The mines are going to have to get bigger and bigger, right? Their footprints are going to get bigger and bigger. Their environmental footprints will get larger. Their long-term liabilities will get larger as well. There's more copper on the seafloor than all the reserves on land. So the International Seabed Authority has done studies just in the Clarion-Clipperton zone, and there's a huge reserves of minerals on the seafloor. So, it only stands to reason. If we're going to protect the planet, part of the way of protecting it is to step back and say, what are we saying yes to and what are we saying no to? If we're saying no to seafloor mining, we're saying yes to bigger and bigger scale mining on land, right? Or we're going to stop mining and go and live in caves.
You've mentioned about a few of the very attractive aspects of the Sawara 1 project, but I realise that you do have a number of other tenements as well. Was there a particular reason why you decided to pursue this project?
The Papua New Guinea government was the first government to grant a exploration licence, right? So that was back in 1997. It always saw the potential there, and they're now a partner in our project, we have a very good relationship with the Papua New Guinea government. So they were very visionary in granting that first licence, and that allowed our company to get out there and start looking. So that was the first licence to be explored, and it's also now the first granted mining licence as well.
What's next for Nautilus, aside from Sawara 1, of course, continuing? Where do you see Nautilus focusing its efforts on in terms of your other exploration licences?
We're initially focused in the Southwest Pacific, largely because that's the area we know very well. There's a lot of other governments who've approached us about their own jurisdictions, and we have discussions with a number of governments and throughout the world about developing seafloor mining within their jurisdictions. As I say, initially the Western Pacific, and we've worked with a number of governments there. The international waters, the International Seabed Association, we've got a licence out there. There's clearly a need to see those resources developed, to meet the demand from these rising economies. So we're going to be part of that. I think that's pretty clear. We're accepted by most people as being the leader. We're well out in front of everybody on how to do this and how to do it well. So we're going to be clearly involved throughout the world by the look of it.
And in terms of Sawara 1, what remain the key challenges in terms of it becoming operational on time and on budget?
The critical path runs through the vessel, so getting the vessel built on time is critical to the mine starting on time in the first half of 2018. That is the main item that needs to be tracked pretty carefully. And I'm pleased to say that at the moment the vessel is on schedule.
And do you plan to stay sort of solely offshore focused company, or do you have plans for diversification, or what is your growth strategy?
We're an offshore minerals development company, and that's where we'll stay, particularly in terms of metalliferous minerals, so copper, gold, zinc, those are the commodities that we prefer to nickel. Those are the commodities we prefer to be in. There's a huge resource base out there on the seafloor waiting to be exploited. Our business model is quite simple. It's very, very modular. You just build more of these things. They're relatively cheap to build, and we've protected the technology around them, so we can just build new ones. So you can't do that very easily on land. You can make it fit whatever growth strategy you want. If you want to be highly leveraged and do the first one and then highly leverage the company and borrow and whatever to do multiple ones, you can go down that path, or you can do it off cash flow. It's whatever our shareholders want to see happen is what we'll do.
And would you say your business model is resistant to a drop in copper demand?
I think so, because the thing that we have is when I first started in the mining industry as a geologist, an very old mate of mine once said, you can't manufacture grade. Right? So mineral deposits have a certain grade, and that's what determines whether they're profitable or not. the beauty of offshore mining is that the grades are much, much higher than they are on land. And what we're seeing now with the technological changes is that the technologies are there now to be able to do this and to do them in a very competitive cost environment and doing it to deposits which are much, much higher grade. So the first deposits to go are always the lowest grade and highest cost ones. They go off the cost curve.
And in terms of the company's achievements, which ones would you say you are most proud of to date?
I think coming up with a system which has such a small environmental and social footprint. That's something which mining industry is quite foreign to the mining industry and oil and gas. So I think we're very proud of that, and I'm very proud of it. The other things though also is that we've been able to take, for me personally, we've been able to take that very small footprint, and then the fact that we are 30 kilometres offshore and we don't impact people, we've been able to sit down with the provincial government and the national government of Papua New Guinea and actually go, all right, now we still want to deliver benefits as part of the project to local people, and we're working with the provincial government to determine what those benefits will be. And the other week when I was there, and we opened just simple things that we take for granted. We've been putting toilets and running water into schools, and when you see these kids turn on a tap, for the first time they've got water when they turn on a tap, rather than having to walk up the road for half an hour to go to the local river or creek to get their fresh water or to wash or whatever, it's a big game changer for these people. So, and that actually gives you a real, to me, those sorts of things are real lifts for me personally to see those happening, because you're delivering these things without impacting their life, you're actually improving it.
Great, thank you very much, Mike. That's a good note to end on, I think.
Thank you.
I'm Ruth Green for Global Island News, and today I've been talking to Mike Johnston, CEO of Nautilus Minerals.